to interrupt the video, but this is future me talking to you while you're watching this. And if you are struggling with a certain part of your IA, or you just need some way to check over your IA, we do personal one-on-one IA classes. So if you want your IA to get a check over, just to make sure you have all the requirements on the marks, makeITsimpleTT.com/register. Okay, cool. Back to the video. So this is the final step in our journey. Welcome to video number 13. Why did I have to do 13 videos? Because I didn't want to make any of the videos ridiculously long. Although some of them ended up ridiculously long. But this one will be the shortest for sure. All we're doing is we are going through the mark scheme to make sure that you have acquired all of the marks. Every single mark is accounted for. This is the most important thing, is because after you do all of this hard work, you don't want to lose any marks for stupidness, for really, really simple stuff. So let's go through. And we're going to go through the mark scheme. Remember, the whole PDF is on the Learn It app, makeITsimpleTT.com/learn it. You go to that app, you will see all the videos in chronological order. You'll see videos for everything else, videos for other subjects, and the PDF for this. And as we grow, that app is just going to become better and better and better, right? So, let's go. We're starting off with the Unit 2 project, right? It says the first set of marks is 5 marks for definition of problem. So we're going to check our document and see if we defined the problem properly. Now, what you want to do is you want to check to see if your table of contents matches these marks, because it makes it easier for the examiner to come and see, okay, they knew exactly what we were marking on and they put that in any table of contents. If you put that in, the examiner has no difficulty whatsoever looking at the table of contents, and if you put it as a PDF where the PDF is hyperlinked, they can just click on it and it will go to the different parts of the document. But either way, we started. Definition of problem. 5 marks for this. Let's go to the definition of the problem. They ask us for, there are 5 marks on a scale of 1 to 5. Weak description, partially accurate, genuinely accurate, completely accurate. That's 5 marks. Now, they don't give any clear description of what you should have, but I have it here. The name of the company, the software system they use, what it intends to do, the problems they face, the negative effects, the proposed steps to correct it. That's 1, 2, 3, 4, 5. That's 6 different things that you're going to make sure you put inside here. And we did that. We put inside all of that. So that there is a proper 1, 2, 3, 4 paragraphs. 4 paragraphs, and we clearly laid out everything. So 5 marks there booked. Next. Techniques of analysis used. We must use sound and relevant techniques. That means techniques means 2. So what are our 2 techniques? We use a questionnaire. Show the questionnaire question, show the interview questions. We show the analysis on the questionnaire with some graphs. We show the analysis on the interview with some summaries. And we summarize clearly what the issues are. So that's there. So they can't say that they're not seeing the techniques of analysis, which is 5 marks, right? Easy marks here. Next one is the data flow diagram. We have to show them the context level diagram. So the context level diagram basically explains everything from one point to the next point, and the arrows are labeled, everything is clear, the numbers are there. So the level 1 diagram is context level, complete and accurate is diagram of all relevant entities. 3 marks, shows of data flows and whatnot. Good, 3 marks there. Problem part now is the level 1 diagram, which is the same 3 marks, however, it's like 10 times the work. Complete and accurate diagram of all relevant processes, data flows, and major data stores. So, complete and accurate means that it has to be complete first, meaning, do you have every single arrow labeled? All the arrows have to have a word on it, all of them have to be labeled, all of them have to be up to date. Data stores, yeah, we have data stores, we have arrows, we have data stores, everything makes sense. We have the options, we have the choices. Remember, your data flow diagram could be way different from mine. It could have a lot more intricacies. It could have a lot more options. Same way, right? So that's 3 marks there. Our data flow diagram is solid. You have to pay attention to making sure your data flow diagram is complete. Make sure it's complete. Leaving out arrows and lines, that's easy ways for them to just take away 1 mark, right? ERD diagram, complete and accurate diagram. So complete and accurate ERD diagram would require you to name everything, underline any primary key, just like how they do in the past papers, and laying out all of the things I need to have. Right, good. ERD diagram is there. Functional and non-functional requirements. This is 3 marks each for your functional requirements and your non-functional requirements. Now, any functional requirements, we put in most of the user interface stuff. Delete record, search for name, request table report, request all. These functional requirements should be informed by your problem definition and your analysis. So your analysis and problem definition are supposed to say, all right, these are the things that we need to fix. So we're going to put those in. Non-functional requirements should also be informed by your knowledge of software engineering. Your knowledge of software engineering clearly in Unit 2 focuses on user interface, putting in more better searching algorithm, clear report layout, user input validation, and putting things in order, and basically what you learned in module 1, which is sorting and searching, right? So we put in those things and we show that the non-functional requirements are there, right? Yeah. So that's the non-functional requirements. Good. Then design specification. Design specification is 4 marks for system structure and diagram. Complete and accurate diagram of all the processes. This is where you are going to start to design how your new program is going to look. Remember, the data flow diagram was on how the program was before. Now you are going to update it to make it better, right? So the design specification shows that the person will get a welcome message. They have to put in a password. After they put in a password, they have the option to choose all of the main options, and then they have to choose which output they want to put to print the discharge, water or critical, and we did all that. So system structuring, 4 marks, because it's very clear, it's very well laid out, and we have no problems there. User interface design, 2 marks. In the user interface design, I explain why you have to put certain things, and then you have to put some words underneath it to tell them, okay, we laid out the menu because of this, we did this because of that. Or there's a lot of justification because this IA is basically justifying why you are making the choices to do software engineering, which is make the software better. So we do the user interface design, cool. Report design, now we're trying to say why the reports are appropriate and well implemented. So in the report design, you have to say, okay, this is how I wanted it, and then you tell them the format was done like this because of blah, 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 blah. 1 sentence is good enough because they just need to know that you didn't just put tabs. You have to say why you left it like that. And I put the report design like this for each one of them because all of them follow the same pattern: ID, surname, first name, age, and status. So if there are different reports, of course you have to put each report the way you put it, but this program only has 3 reports in it because that's all that's necessary. All right, next we have to go to algorithm design. Algorithm design, it shouldn't appropriate design for the algorithm. The key thing here is it mustn't be a carbon copy of your code. So you have to literally go through your algorithm and be very, very, very precise and clear about the certain things that you do and you don't do. So you don't want to have double equal signs. You don't want to have semicolons. You see how like I have here? Semicolons and thing? This? Right, for any time you're going through this, make sure you check that very clearly and ensure that you don't have any semicolons anywhere, no double equal signs, no printf, no scanf, and the words, especially the prints, match back to what is in the code. And you double check to make sure it matches up. You're going to have to spend a lot of time going through this to make sure, but you don't want to lose mark for algorithm design because you made it look like C programming and you did a carbon copy of it and then try to, let's call this word, find and replace. You can't find and replace every single semicolon. You can't find and replace every single printf. You'll make mistakes. So you're going to have to go through it step by step, one at a time, and do the hard work, or else you'll lose that 1 mark. Or you will lose a mark inside of this algorithm design part. No bueno, no good. Choice of appropriate data structures. You will tell them that you use the data structures. It's basically the same thing from Unit 1. Unless you change the data structures. If in Unit 1 you did an array based program and then you updated it to a structures based one, You have to explain your array structures, understand why it's holding different pieces of data, blah, 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 explain that. 3 paragraphs should be good because they want you to show that you understand why you use the data structure that you use, whether it's an array of structures or linked list. If you use a linked list, I'm sorry for you, yeah, and if you use a linked list, please make sure you can explain what a linked list does and why you use a linked list. It's basically theory. You're answering a question here. You're basically answering a question. All right. Next is coding and testing. So coding and testing, code achieves functionality is, so when you reach coding and testing, you're pasting all the code inside here. Put the whole code, your final code that was working, that you're using the test plan, copy that and paste it there. No questions asked. And you have to use, if you're using Google Docs, there's an extension called Code Blocks. Code Blocks. Download this extension called Code Blocks. Copy the code in and then format it so that it will look like code. Code. And it will be easier for the examiner to read and understand. Even though some of it will go over to the next line, we can't fight that. That's just character returns. Yeah. Word wrap, they call it. Right. So we go back here, code response to design. Now we have to show, code achieves functionality. We have to show. This is very, very important. You can't just paste your code and expect them to go through your code and check for all of the things. They should do that, but they don't always do that, and I know that from a reliable source. What you want to do is you want to make sure that each one of these headings here, code achieves functionality, you have a section that shows them everything that they're asking for. They want to see documentation, error trapped in, correct output, usability and reporting. Okay, cool, let's go. So we're going to start by showing them documentation. Every time there's documentation in your code, show them documentation. Explain why you documented certain things, because remember, you are justifying why you must get the marks. So you show them comments. You show them comments for a function. You show them comments for another function. Why you name certain things. Things like global variables. You want to show them that you could put comments for that because those are things that are commentable. Every structure, you want to name the structure, explain why the structure was put the way it was. Name the function. Comment on the function. Explain why the function doing what it was. I left a comment in for the old search saying this search was deprecated because there was a better search algorithm, blah, blah, blah. All those are comments because those show that you understand the concept of comments. Comments are there to ensure that the next person who has to see this program will understand it better. So you do all that comments. Your next job is error trapping. Error trapping is what they have next, error trapping. What you want to do is show that you have printfs in place for if they don't put valid things in. Passcode incorrect, not a valid input. The file may be empty, patient does not exist, invalid choice. Please choose a valid number. All of those error traps you want to show. You should have about maybe 4 or 5, depending on the type of program that you do. Find as much as possible. If you reach up to 5, that's good. You've done your error trapping. If you have more than that, put all. Don't let them even think that you didn't know what you were doing. Correct output. Correct output will show that the program responds to what it was supposed to do. So you're showing them the input file, you're showing them the output file, and you're like, yeah, exactly what I asked to do, which is take this input file, collect all the information, and print it out to different output files. Boom, that's correct output. Then there's usability and reporting. Usability. So no, we're still on code response to design. Yeah, we have reporting, code response to design. Oh, right, this part here that says usability and reporting. Did I put in usability and reporting? Oh no, the reporting inside here. Yeah. So this is usability and reporting. Right. You see why I had to go through this? Usability and reporting. So I need to show that the program is being used properly. Code response to design will show that the design is laid out a particular way. Menu is laid out neatly. Sorry, I need to put words underneath this. Menu is laid out neatly and spaced out. Spaced out. matching design. Right, so we're going to lay out everything and show that it's matching the design. Good. Right, so there's usability and reporting. So we went through all of this here, 4 or 5 marks. We're showing that it's clearly doing all of these things here. Documentation, error trapping, correct output, usability, and reporting. We clearly lay that out because we put an actual section for reporting, an actual section for correct output, an actual section for error trapping, an actual section for documentation. And if they can't see it there, then they can at least go through your code and see it, which they should do, right? Code response to design. Oh, we put that inside here? Yeah, code response to design is inside here. So we're showing that the design that we had on top matches back. Code response to design is 5. Achieves all the design specifications. The design specifications would have been, according to our, this part on top here, design specification is to show that the system was structured the way it's supposed to do with the menu, the user interface, report design, all of that match back up. So code response to design, all print screen, so I'll put a little word underneath here saying all print screens show, all print screens show that the code, the output of the code matches the design that was planned, including the user interface, report layout, and what they want, design specification, report design, yeah, UI and report layout. Right, so we have all the print screens showing it, so we don't need to tell this examiner anything else. We like, listen, we have everything shown there for you. Right, test plans using exhaustive data set, 5 marks for this. So we're going through the test plan and we see we have an exhaustive data set. We have one test that checks the input files. That was a good test. We have the print screens to prove it. We have a next test that proves the password function works. That's exhaustive because you should test the password. We have the menu function. We tested that clearly. We showed everything happens properly with that menu. We have the add patient function, which is important to show everything being updated. And we have the invalid status. I put 7 here. Invalid status 7, right? So that's a test that shows, make sure what you have in the table here matches your print screen. That's very important because then they will think you contrived your test plan, but you didn't contrive a test plan. You know what you were doing, right? That's 5, and then we keep going. Test 6, testing the report printing. We test the report printing. We show that the file was empty at the start, and we show the input file, and we show when we choose the option, the output that we get. When we choose which option, the output that we get. Test 7, we test again. We show them everything with respect to the delete function and all the information there. And we just show test 8, which is showing that the information was sorted. And when we show the patient file was sorted after we print it out, thank you for using the system. Everything was printed out with a particular order, and it shows the updated sorted file, and you will see it in order. That shows the sort. And then that's 5 marks. Now, this part here, this is where it gets weird. Communication and presentation. Communicate information in a logical ways using correct grammar and appropriate jargon all of the time. What you want to do is there is no appendix, right? There's nothing for us to put in the appendix, so I just have the appendix there for no reason. So I'll just take the appendix out. We don't have to put the graphs and the screenshots because they will accept it in the inline, right? Now, you have to use appropriate jargon. Jargon is it. We are clearly showing that our information is logical, in a logical way, using correct grammar and appropriate jargon all of the time. Now, we have to ask ourselves, is this logically presented? Yes, our table of contents shows that it's logically presented. You can see heading 1s, you can see heading 2s, you can see clear layouts, you can see different sections, all of that. That's logically presented. Appropriate jargon requires us to use words that make sense. So let me show you. Let's go to system structure. Let's go to appropriate data structures. Here's the jargon I want to use. Patience is the name of the structure. P is the name of the array of structures. The max size is a global variable. You see words like this? Global variable, define, data types, thus making it easier to group patients for greater searchability. Structure contains 4 pieces of data that mimic things: integers, age and status, they are whole numbers, strings, all the little things that you need to be able to say in a program about why you use ints, why you use libraries, why you use this, which library did what, blah, 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 blah. And inside you have comments inside the code that clearly shows that you understand the libraries used, the things, the pause, the this, the that, all of those things. You want to use computer science words. You don't want to use simple words like that. You want to use words like data type. You want to use words like functionality, layout, usability. Anywhere you could use a word that comes from module 2, which is software engineering, you want to use that. And once you do that, communicate that in a logical way all of the time. This is the hardest for 6 marks to get, because a CD could give you 5 to 6. So it's possible you could get 5 to 6. How does the examiner really determine that you use appropriate jargon? Wherever you use words, make sure it sounds like you're doing computer science. Make sure it sounds like you're doing computer science. And then once you get there, you're good. That is the breakdown of the IA. So this here is ready to ship out. I'm going to convert this to a PDF. I'm going to put it inside the app, and you're going to have access to it. 77 pages of clear information. What I have done is, wherever I put information about what you should do, I put it in red, and then I put the sample underneath it. So everything that's in red gives you the breakdown of what you should try to do and how you should pay attention to it. And this is free, totally free. So this is how you test to see if your IA is, your Unit 2 IA is on point and it's ready to go. If you watch this video alone, good. I'm glad that you watched this video alone and you saw everything that you needed to see about the way you get your marks in your Unit 2 IA. If you're not too sure about certain things, there are 12 other videos of these that came before that shows the whole IA from start to finish. You might want to check it out. If you download the Learn It app, makeITsimpleTT.com/learn it, you will see the playlist of all the videos and you will see this document, and it will help you polish up your IA. If you've gone through this whole journey with me to go from video 1 all the way up to this video 13, thank you very much. Leave a comment. Let me know that I changed your life. If I did. If I didn't change your life, that's okay. Leave a comment still. Let me know how I didn't change your life. And I want a neat bonus. Fun fact, this took me 2 years to do, because I started in 1 year and then I just ran out of time before life took over, and then I just had to wait until I got the opportunity again to do it, and I did it, and I'm finished. And this is a very proud moment, so thanks. Right, so download the app, support makeITsimpleTT, and go mash up ComSci and be a really good computer scientist. The Caribbean needs you. The Caribbean needs you. So, until another video, I guess, I don't know what else I'll do again, but there are videos that I do for almost everything. So, check it out. I'll see you on the other side.